How you doing, guys? It's me, Mr. Herb. I'm here to help you learn the systems of equations graphing. Now, you have already done a discovery worksheet in terms of systems of equations with graphing. So if you feel like you already have a strong understanding through there, feel free to skip through a lot of this video. It's just here to help you out and give you additional support with it. Or if you feel like you're struggling, come back to it and it'll help you out. So our objective of this video is students will be able to find the solution of a systems of equation problem through graphing. So what you've been working with in terms of that worksheet was called the systems of equations. System of equations deals with any sort of group of equations, more than two, that has multiple different variables, and you can solve to get a solution for which all of the equations hold true. So two equations are like y equals 3x plus 4 and y equals 3x. If I put those two together, that's called a system of equations. And I don't mean putting together through adding or subtracting or something like that. I'm just talking about those two equations are a system of equations. And a solution of the equations of a system of equations is an ordered pair of numbers that satisfies both equations. So when we're talking about ordered pair, we're talking about kind of a point in a graph. We're talking about an intersection of these two lines. So a system of two linear equations can have no solutions, one solutions, or an infinite amount of solutions. So I'm going to start off with one solutions and we'll work our way up to the other two. So here we start off with these two lines. Y equals negative x plus 2 and y equals 3x minus 2. Now we know that these are not parallel or perpendicular lines or anything like that, or even the same line. We know that these are two different lines. So I start off with, let's go with this first one. So it has a intercept of 2 and then a slope of negative 1. So I'm just going to graph that real quick. Okay, and I apologize if the graph's a little rough. And then I have y equals 3x minus 2. So I start off at my y-intercept, which is negative 2. And then I go up 3 to the right 1, or down 3 to the left 1. Now again, throughout these videos, if you have any questions or just want us to clarify anything, please feel free to pause it, rewatch it, and if you still don't understand it, raise your hand and we will come help you out. So here, I have found that these two equations of the lines intersect at this point specifically right there, and that point is 1 comma 1. So that's going to be my solution for this equation, and or this system of equations. And if I want to check to make sure that that's going to work, which we always do, all we have to do is plug it back in. So we do 1 equals negative 1 plus 2, so that is equal to negative 1, so that checks out. And then 1 equals 3 times 1, minus 2, and so that'll give us 3 minus 2, which is 1. So that checks out. So we know that this is a solution because it satisfies both of the equations, not just one. So here I have an equation that is not already solved for y. So the first thing that I want to do here is solve this equation. So to do that, the first thing I'm going to do is add x to both sides. So that's going to give me 2y equals x plus 2. And then I'll divide everything by 2. So that's going to give me y equals 1/2 x plus 1. Now, comparing these two equations, we realize that they are the exact same line, right? If I were to graph this first one, I would start off with 1 and then go up 1 to the right 2, or down 1 to the left 2, and I would get my equation of the line. I do the exact same thing with my other one. Start at 1, go up 1 to the right 2, down 1 to the right 2, and I'm going to get the equation of the exact same line. Now, because these two are the exact same line, that means they're going to intersect an infinite amount of times. Any point that exists on this line is going to be a solution. So that means the point, let's see, 2 comma 2 is a solution, 4 comma 3, those would all be solutions, and so on and so forth. I'm actually going to have here infinite solutions. Infinite solutions. So anytime that you have an equation and it turns out that the lines are the exact same, then that means infinite solutions. So exact same lines means infinite solutions. And by that I mean simplified down, they're the exact same thing, or solve for y, the exact same equation. So let's look at the different types. With one solution, that means that they're going to intersect at one point. They have to have different slopes and different, well, they don't have to have different y-intercepts, but they have to have different slopes. The equations are consistent and independent. We're going to have infinitely many solutions, as we said, if we have the exact same line, meaning the same slope and the same y-intercept. Okay. And then lastly, the lines are parallel. That means they're going to have no solution. These equations or these lines are never going to intersect. Obviously, they have the exact same slope, but different y-intercepts. So what I would like you to do now is to pause the video and solve this equation, solve this first one for y, and graph both of these lines. Let me see what you see. So pause the video right now, solve, and then graph. Okay, so let's assume that you have it graphed by now and you realize that the equation is y equals 3/4 x minus 3. Now looking at these equations, I notice that they have the same slope but different y-intercept, meaning that these two are going to be parallel. So here's that first line. I'm going to use red to designate the second line. And there we go. We see that these are parallel lines, never going to intersect, so no solutions would be our example here, would be our answer. Okay, moving on. Next one. Again, pause the video, solve this one, and then come back when you're done. So we find that this first one has an equation of y equals 3/2 x minus 11/2. And the same can be said of this equation. So they are the exact same line. So without even having to graph these, I already know that this is going to be an infinite amount of solutions. So infinite solutions, because they're going to intersect at literally every point. Now, the one thing that we have seen in terms of graphing is it works really well if it's going to hit specifically on the grid. But here I have shown two different equations. This one is, if we simplify it down, it's y equals negative 2/3 x plus 2. And the other one is y equals negative 3x plus 5. Now we can see an intersection happens here. And if you were to graph this more precisely, maybe with nicer lines, you would be able to tell it's still not going to hit any specific grid point. Now you might be able to kind of wager that it might be 1.5 and 1, but we can't be for certain. So what we need to do, if we anytime we have an equation and we can't see specifically where it's going to hit on a integer value, that's when we have to use a different kind of solving method. And that's what we're going to do in the next video, which is solving systems of equations through substitutions. All right. Well, if you have any questions, make sure you raise your hand or rewatch any parts of the video. And thank you for watching.